So, right now I'm building a house, right? And we use what's called blueprints. You guys know what blueprints are?
Yes.
Okay, they're the big drawings that show the builder how big to make a house. All right. Now, on these blueprints, my blueprints have a scale where 1/4 of an inch on the drawing is equal to 1 foot in real life. All right. So what the builder can do is they can take a tape measure and they can lay out my blueprint and they can measure on the blueprint and it will tell them how big, how long, how wide to make a room. Okay? So that's what we're going to do right here. Now, first thing that I want you to notice about this is down here there is a key. Alright? Now, we've talked about all the different things that we can solve using proportions. You can use proportions to solve conversions. You can use proportions to find the height of objects. Alright? Like the school that we were trying to do. You can use proportions to find percent change. You can use proportions to find the price of a refrigerator that's 30% off. You can use proportions to figure out the amount of tip you should leave at a restaurant. And you can use proportions to read blueprints and maps. Now, whenever you're using a blueprint or a map, you're going to have to find something that says this, the key or the scale. Anytime you see a key or a scale, that is your first ratio. So, on your whiteboards, I want you to set up your proportion and put your key in immediately. Once you have the labels, you want to carry your labels across. So this will be inches and feet over here. Now, if I'm building this, number one, it says, what is the actual length of the Impressionism art room? So I'm building this room, and I need to figure out how big to make it. Or maybe I've got the blueprints, and I have to figure out how much carpet it needs. Whatever is the case, I need to figure out how big this is. So I'm going to measure it. Now, obviously, this drawing is a little bit bigger because it's blown up on here than what it should be. But we'll figure it out anyways, based on this, how big it should be. So, if I need to know the Impressionism art room, the length of that, I'm going to measure the length of it, and I will see, we'll call it 20 inches. Alright? So, if this is 20 inches across, what is the actual length of the Imperial art room? I'm sorry, the Impressionism art room. What is the actual length of that?
Is it 20 inches, right?
20 inches. So, I am going to put 20 inches up here. Oscar, what is the actual length of the Impressionism art room? 400 feet. All right? The Impressionism art room is 400 feet long. Number two, find the actual dimensions of the Baroque art room. Now it says the actual dimensions. That means I need length and width. So, as I measure the length of this, this is 24 inches long. And as I measure the width, it is 11 inches wide. So, what are the actual dimensions? What are the actual dimensions of that room? Remember, your first ratio needs to be your key or your scale. So your first ratio should be 1 inch equals 20 feet. Your first ratio needs to be 1 inch is 20 feet. That is the key. Bailey, what was the actual width of the Baroque art room?
220 feet.
Okay, the actual width right here, or the width right here, if we put 11 inches in here, this is going to be 220 feet. So this will be 220 feet. Tristan, did you have the actual length of the Baroque art room?
Really?
Okay. We need to solve this twice, don't we? We need to do with 11 inches and we need to do with 24 inches. Lyndon, did you have that? 480. When we put 24 inches in, it's going to come out to 480 feet. Alright, so when you need two dimensions, length and width, you will have to do it twice. Now, one more thing. I'm probably done writing inches and feet. The way I'm going to write it is like this. This says 11 inches with 2 marks. This says 220 feet with 1 mark. Here's how I remember the difference between 1 and 2. Inches has 2 syllables, so there's 2 marks. Feet has 1 syllable, so there's 1 mark. Okay? So, inches is 2 mark. Feet is 1 mark. All right. Now, it says find the length of each model on the scale drawing with the given scale. So, right here, we've got a train car that is 16 feet long. The scale for the model is 1 inch equals 8 feet. What is the length of the model? Anytime you have a key or a scale, that's your first ratio. Put that in right away. 1 inch is 8 feet. This will be our first ratio. 1 inch, 8 feet. Carry your units across, inches and feet. I'm going to put 16, this is 16 feet, so I have to put it with feet. As I work this out, Kenlin, how many inches is that? 2 inches, very good. Our model is 2 inches long. Do this. St. Louis Arch is 192 meters tall. What is the height of the model? The key is the key. That's deep thinking, isn't it? The key is the key. This will be very, very easy if you write down the key first. If you write down the scale. So, here's our proportion. Our scale is the first, 1 centimeter, 4 meters. Carry your units across. All right, now, where do I put this 192? Jaylee, top or bottom? Bottom. It's 192 meters. That's where it is. 192 meters. No, I don't think I did. I hope not. What's my actual height, Jaylee?
48 centimeters.
Okay. 48 centimeters is my actual height. 48 centimeters. How about that gator? Figure out the actual length of a model.
Now it's working. I think it's mad. I think it's telling us that we need.
I think something is wrong with my computer.
No. I would freeze it.
Good.
Just
Yep, 13.5 feet. About 2 years ago, my wife had LASIK surgery. All right. Yep, it's the eye surgery. It's where the doctor, the surgeon, kind of burns off part of your cornea, I believe, with a laser.
Does it hurt? No. You can't.
No, it doesn't. It doesn't really hurt. Okay. So the surgeon's in there, and he's going to burn off part of my wife's cornea with a laser. Now, he goes and he's getting ready to set his machine and set up the computer, set up the laser and stuff, and he's doing all of his calculations in his head, and then putting stuff in. Am I impressed with him?
No.
Not really. I don't want my surgeon doing stuff in his head. What's going to impress me is when I see him writing down the measurements that he's taken and putting them into the conversion, and I can see him working it. That's when I'm going to be impressed. All right? There is no, people always ask, when are we going to use this in real life? There is no real life application where you have to think about math quickly, where speed matters. All right? There is no real life application where there are few real life applications where being able to do something in your head matters. Mathematics is about precision. All right? Precision. When you are working with math, you have to be right. You don't have to be able to do it in your head. You don't have to be able to do it fast, but you must be able to do it right. I'm going to put my scale as the first one. 2 inches is 1.5 feet. Carry your units across, inches and feet. The length of my alligator is 13.5 feet. What is the length in inches? Amy, how many? 18 inches. My alligator is 18 inches long. It's not a very big alligator. All right. Here is a comic for you. So, we see a professor and a duck. Their ship is sinking. And it says, "So, Professor Jenkins, my old nemesis." What does nemesis mean? My old enemy. So they are old enemies, like old spy movies or something. They're old enemies. "So, Professor Jenkins, my old nemesis, we meet again, but this time the advantage is mine. Ha ha ha." Because he can swim.
It'd be funny if you just like the whale's tail in the back of his mouth. They're on top of the whale, not on top of the river. Just make sure not to swim on the whale.
Alright.
Those ducks I used to have a